Different bases. Base 10, which is the base we usually use from day to day, has 10 digits. Notice 1 through 9, and then 0. That's 10 digits. Or if you like, 10 numerals available, or 10 numerals that we need to work in base 10. To work in base 5, you need 5 numerals, 5 digits, 1 through 4, and the 0. Also notice that the base that's named, that digit is not available. Base 10 does not have a 10. We would have to come up with a 10 and all the numbers above that using the digits that we have available. Take, for example, base 3. There's no 3 in the list, but we have 3 digits available. To come up with numbers above 2, we would have to use these that are available. So to come up with a 3, I would have to use these 3 to come up with the naming of a 3. Base 10, going back to it, to name a 10, I would have to use a 1 and a 0. But notice there's no symbol for 10. I have to use the ones that are available. So notice the name of the base is not on the list. Counting in other bases. Base 5 has only the following symbols, numerals available. 0, 1, 2, 3, 4. 5 symbols. Of these numerals, only 1, 2, 3, 4 are counting numbers. And the reason we mention counting is because of the problem we're going to be working shortly. The counting ones, even though these are all base 5, the ones you count with are 1, 2, 3, 4. And now let's look at a base 25 system. A base 25 system would have 25 digits available, or you need 25 digits to be able to work in that system. So it's true for any system. So if they say base 5, there are 5 digits available, 5 digits needed, and so forth. Write the first 15 counting numbers for base 5. So these are the ones we have for base 5. Notice we're crossing out the 0 because 0 is not a counting number. So now we just have 1, 2, 3, 4. And from here, since this is base 5, notice there's no 5 symbol for 5. We're going to have to use these to create the 5, the 6, the 7, all the way to 15. So how do you get the 1 after the 4? Well, you add 1 to it. So 4 plus 1 is 5. But we said that in base 5, there's no symbol for 5. We have to use these symbols here to come up with a 5. 5 is not available. So 4 plus 1 is 5. Since we reached a group of 5, we need to carry over. So every time you reach a group that names the base, you have to carry over. Since this is base 5 and I reached the 5, I have to carry over. So 4 plus 1, notice it's a 0 because we're going to carry the 5 over. We're going to carry 1 5 over. That's why we have a 1 here. One group of 5 was carried over. Since that was all we had, 5, this position gets a 0. So the number after 4 in base 5 looks like this. We would say, well, that's a 10. Yeah, that's in base 10, but this is base 5. That's the way a 5 looks like in base 5. So you get the next one, you add 1 more, and you're going to keep doing that each time. So you add 1 more. This would be like a 6 in our base 10, right? But in base 5, this is what a 6 looks like. The 6 would have been occupying that position in base 10. But since this is base 5, this is the number that's occupying that position. And then you add 1 to the 11, and you keep adding until you add and get something that reaches a 5. Anytime you reach a 5 in base 5, you have to carry over. So here we have to carry over. So we added 1 to the 14. We reached the 5, so I can't put 15 there because there's no 5 numeral in base 5. So what I do is I say 14 plus 1. 4 plus 1 is 5. But since I'm carrying it over, I moved it, right? One group of 5. This position is a 0, and then 1 plus 1 is 2 because we carried the 5 over. Now, if you keep doing this, this would be the list of counting numbers, the first 15 counting numbers in base 5. This is what they look like. And notice they're counting, so I can't include the 0 because I have to have counting numbers.